Hey, I want to talk about the chain rule, but specific to functions. I won't go through all of them. We'll use them all in a moment, but we have function-specific rules like the power rule, the one for exponentials and natural logs, and some others that are very specific to that function in general. And usually when we're given those derivatives, like the power rule, we're used to derivative of x to the n. That is n times x, and we decrease the power by 1. And in those cases, x is a single variable. But because of this chain rule with the f and the g inside of it, we can kind of change those. Don't really have to change our thinking, but we use u to represent an expression or another function. So in the chain rule idea where we had f of g, the g would be a u, which we're just replacing the x value with. So we'd still have the same chain power rule function, but because we don't have just a single variable inside the function, we have an expression, we have to tack on that g prime, or as we might call it, u prime in this case. So the u is the same thing as g, and u prime is the same thing as g prime. So we can use this a little bit quicker and a little bit more efficient with certain functions. So let's see which way we go here. Okay, so here are the, we've got the same problems we just did using the composite function notation, but I want to do them using this u version. So we had y equals 7 times the quantity of 3x squared plus 5x plus 4. So this is a power function. Power rule, and the u in here, just like we did before, what we called g, was 3x squared plus 5x minus 4. So we can take the derivative by just, I don't know why this happens. Let's get back to where we were. Okay. So we can use the power rule to say that we've got 7u to the third, and leave the 7 there, bring the 3 out front, just leave a space, and reduce it down to 2. Now, in the version of that power rule function, with u substitution, u goes inside, u prime goes outside. So we'll fill that back in. So we'll have 3x squared minus 5x minus 4 on the inside. And if we can look at that and take the derivative, we don't necessarily have to rewrite it. So derivative of that would be 6x minus 5. So if I wanted to clean that up, I could write it as y prime, forgot my prime, y prime equals 21 quantity 3x squared minus 5x minus 4 squared times 6x minus 5. And you can check that against what we did earlier with the composite functions. The next one, natural log of 4x minus 5. So the 4x minus 5 is the u, because we know how to take the derivative of natural log. So let's just jump right in here. Y prime will be, derivative of natural log is 1 over x, but we're going to call it 1 over u, so that u is 4x minus 5. So every time I label a u here, you should be able to go back and see that that was the g in the other version. And then we'll put a u prime on the outside, so times 4. So that'll look a little bit better if I clean it up. I don't have to, but as y prime equals 4 over 4x minus 5. All these might be able to have some adjustment as far as cleaning up, but it's not necessary. But you can see in here the original u and the u prime. All right, go down just a little bit. 6 times e to the 12x plus 4. So before the 12x plus 4 was the g, we understand that to be the u. So let's see here. Y prime equals, the 6 will stay there. It'll be e to the u. So if u is 12x plus 4, it's still e to the 12x plus 4. But then we tack on the u prime, which will be just 12 in this case. So up here, this is the u. And then out to the side is the u prime. Last one here, y equals 4 times the cube root of 5x to negative 3 plus 8x. Definitely rewrite this. Y equals 4 times 5 x to the negative 3 plus 8x, and that's all raised to the 1/3. So when rewritten, you can see you're using a power rule. So what are you raising to the power? The 5x to the negative 3 plus 8x, so that's your u. So when you go to your derivative, y prime equals the 4 coefficient stays there, the 1/3 comes out front, the power comes out front, then the power is reduced to negative 2/3, and then inside you will have your original u, and on the outside you will have u prime. So that is 5x to the negative 3 plus 8x inside. On the outside it'll be negative 15x to the negative 4 plus 8. So two different ways. Here you can be very specific to the function you're looking at, and you might not have to think as deep or write as much. But in other cases, if something's a little bit more complicated, maybe the composite f and g make more sense to you. But keep in mind, every one of these where I labeled u would have been the same thing as g in the previous version. All right, thank you.